Hi there, this is question 5 from a trigonometry assessment for core 3, and we're looking at a few parts of this question. The first one is asking us to use one of the compound angle formulae to try and express cos 3x in terms of just cos x's only. So if I just reduce that, we have a think about how we're going to do that. So we need to take cos 3x and somehow split it into an a and a b. The only real options are these here. So if we use this expansion, we've got cos x cos 2x. The sign changes when you're doing the cos compound angle formulae, and we're ending with minus sine x sine 2x. Now we succeeded in getting one of our cos x's, but the others still need a bit of work on them. So the first thing I'm going to try and do is change cos 2x into something in terms of just cos x, and to do that I'm going to need to use the double angle formulae. So if I just put those down here, we've got cos 2x. Now we've got options. We've got cos squared x minus sine squared x. We've got 2 cos squared x minus 1, and we've got 1 minus 2 sine squared x. You need to know those, and seeing as we're aiming for in terms of cos x's, it would seem logical to try and choose the second one. So if we go and place that in, we've got cos x, and we're replacing our cos 2x by 2 cos squared x minus 1. I'll leave the sine x for the moment, but then one of your other double angle formulae is that sine 2x is 2 sine x cos x. So if we replace that in there, we're now getting slightly closer. There's no 2x's in our expression, only x's. If I expand this one, I get 2 cos cubed x minus cos x, and if I expand the right hand bracket, I end up with 2 sine squared x cos x. So almost there. The only problem now is we've got a sine squared, but hopefully you remember from C2 that we can express sine squared x as 1 minus cos squared x, because sine squared x plus cos squared x is equal to 1. So if we add that in as well, we end up with 2 cos cubed x minus cos x, and then we replace it with 1 minus cos squared x. We're going to need to expand that bracket, and it gives us 2 times 1 and times the cos x, so we end up with 2 cos x minus 2 times the minus, so that's with positive, and the cos squared times the extra cos will give us cos cubed x. So all together, we'll just simplify it, we're going to end up with 4 cos cubed x minus 3 cos x. We've now successfully expressed cos 3x as 4 cos cubed x minus 3 cos x. Okay, I'm now going to move on to part B. So if you'll just excuse me while I get rid of that bit, you can always rewind the video to have a look at that again if you need to. Moving on to part B. Part B asks us to prove that this expression of two fractions here is equal to 2 sec x. So that's what we're going to have a look at now. The most obvious approach to go for is that we've got two fractions that are being added together, so why not treat them like two fractions that are being added together and give them a common denominator. To do that, we're just going to have to multiply the two denominators we've got. So the common denominator is going to be cos x multiplied by 1 plus sine x. To achieve that, we're going to have to multiply the top by the same, so we're going to end up with cos x 1 plus sine x. Pardon me, getting a bit too hasty. The factor that's missing from the bottom of that one is cos x, so we're going to need to multiply it by cos x, aren't we? And for the right hand side, the factor missing from the bottom of that one is a 1 plus sine x, so we're going to end up with 1 plus sine x squared. And because that common denominator, we can write it as that. Now, what we're going to need to do is we're going to need to expand the right hand bracket. Leave the cos squared x as it is, and if we expand this bracket, remembering it's like multiplying 1 plus sine x by 1 plus sine x, so you're going to need to multiply 1 by 1, 1 by sine x, and sine x by 1, so you end up with 2 sine x's, and then also a sine squared x. I'm not multiplying out the bottom because I have a sneaky suspicion that there'll be some cancelling to do in a moment. Simplifying the top, you'll see we've got a cos squared x plus sine squared x, which is just 1. Add that to the other one, and we end up with 2 plus 2 sine x all over that same denominator we've been working with. And hopefully you've spotted it now that if we take a factor of 2 out of the top, we end up with 1 plus sine x there, and we've got a 1 plus sine x on the bottom as well. So we can do some cancelling, and we end up with 2 over cos x, and 1 over cos x is cosec. Sorry, is sec. So we end up with 2 sec x. Hope that helped. Now, our final part says hence find the solutions to this is all equal to 4. So if I just move our double angle formula out of the way, we can have a look at the final part. So that's the very same expression we've just simplified down to 2 sec x. If we divide by 2, then we've got sec x is equal to 4 over 2, or 2, and then we know that that's the same as 1 over cos, and that's equal to 2, sorry, getting a little slightly ahead of myself, which means that cos x must be a half. Now just to check again, are we dealing with radians or degrees? And we can see here that we're dealing with radians. So if we find out what cos of a half, and this is one you should really know, is that comes out as pi by 3. Now there are other solutions though, so if you just think about your cos graph, which starts at 1 and goes back up to 1 by the time it gets to 2 pi, we've found this one here. So that's the solution we found. But don't forget, if you pan across, there'll be a similar one, and it's symmetrical about 180, so there'll be another one over here, which is pi by 3 below 2 pi. So if you take pi by 3 away from 2 pi, you end up with 5 pi over 3. And those are our two solutions for that final part.